Hello, Math 10. We are going to be talking about the last section in Chapter 1 of Math 10. So here we are at the end. So we are going to be looking at basically more square root stuff. And it turns out, you might be wondering, like, why did we do all these exponents all of a sudden? And as you found out at the end of 1.5, it turns out square roots are also exponents. So they follow the exponent laws just as much as any exponent does. And so we can use those to, mess around with square roots. There's some important stuff to learn about how we actually write square roots. There's going to be some terms to know, and also some, operations that you can do with square roots that you'll sort of be expected to know, I guess, coming up. So let's do it. We'll start off with multiplying square roots. So this is going to be like question 1 in the workbook. I got it open. Here we go. It's like find each product, and they're like boom, boom, boom. Just multiply some square roots together. So it's not too hard to multiply square roots together. For example, let's do like the square root. That's an ugly one, hey? Still getting the hang of it. So the square root of 3 times the square root of 5. So it turns out when you're multiplying square roots, it's just a power rule that you can turn this into sort of one big root with the product inside. It's just a special, not even special, it's just straight up power rule from the exponent laws. So this is basically the same as saying the square root of 3 times 5, which is the square root of 15. So there you go. If you're asked to multiply 2 roots together, you can just do it like that. You can take the square root and basically make it longer and take in the whole multiplication string. So that's that. You might find some, not tricky questions, but sometimes you'll get something that will result in an actual perfect square that's taking the square root. So for example, the square root of 8 times the square root of 2, that works out to the square root of 16. So then you can finish that off and actually take the square root of 16, because 16 is a perfect square, so that equals 4. And there it is. So I hope that is pretty clear on how to do that. You're going to have one of the columns from exercise 1 to do that, to practice that, and hopefully that goes well. Just a reminder that also applies to cube roots as well. So cube roots are going to obey the same thing, but they only work with other cube roots. And same with things, square roots. You can multiply 2 square roots together and use this, but you couldn't multiply like a square root and a cube root and expect to be able to do this. So cube roots stick with cube roots, square roots stick with square roots, and nary the twain shall meet. So that's sort of the idea there. Okay, so hopefully that's clear. We're also going to be looking at a couple other terms here. This is often what I have found in the past for students to get, I guess, maybe like hung up is a good word on it, because it turns out it's not actually that wild of an idea, but sometimes it's just baffling. Like, depends on like how it's presented. So if you come away from this lesson thinking, what just happened, then fear not. It's probably just my explanation wasn't very good. I will look at it again, or you could send me a message on Teams. But the actual like operation here is going to be pretty straightforward. We're going to learn about 2 terms, entire root versus mixed root. And then we're going to learn how to convert like from one to the other, basically. So let's take a look at what an entire root is. Entire roots are things like the square root of 32. Right? Square root of 32. The entire thing is in the square root. That's exactly what an entire root is. Most of the square roots you've seen in your life are entire roots. We're also going to learn about this new thing called the mixed root. So the mixed root is something like, it has a number on the outside, like 4, and then square root 2 on the inside. And what this means is 4 times the square root of 2. So there's no like multiplication sign in between there, but it's implied. So this is 4 times square root 2. So that's what a mixed root looks like. It has a non-square root multiplied onto a square root. And it turns out that the square root of 32 and 4 times the square root of 2, they're actually equal to each other. They are the same. And if you don't believe me, you can punch into a calculator, you get 4.5 7 roughly if you round it. But it's an irrational number. It goes on forever because it's not a perfect square. And yeah, that's what we're going to learn about basically. How do you convert between the two? And what we just did about multiplying roots, that's like a warm-up activity to get into this. We're kind of going to go backwards. We're going to start here and we're going to work backwards to break it up. That's going to be our technique for converting entire roots to mixed roots and back and forth. So let's take a look at an example of converting. Let's see it. Let me just take a look. We're going to skip question 2. Here's a question 3, for example. This is us going to be asked to take these entire roots and convert them to mixed roots. So this will be question 3. So let's take an example of the first question. It says square root of, oh man, I'll get the hang of this one day, folks. One day my pen skills will be up to your standards. So the square root of 20, how do we turn that into a mixed root? It's an entire root right now. So what's the game that we play? Well, you can make a factor tree for 20, and you look for anything that you could take the square root of evenly, like a perfect square. Or you can go all the way down to prime factorization and look for like pairs of numbers, pairs of prime numbers, and you could use those to sort of figure out the square roots. So I'll just do this one because this one, like, it's not too hard to see sort of where the perfect square is, right? Because 20 is just 4 times 5. There's not many other factors there. So this one you might actually have just seen off the bat. So 4 times 5 gives us 20, right? And just like we did before, we kind of combined the multiplication together to get an entire, from 2 entire roots to 1 entire root. Well, now we can go in backwards, and we can split this up using the same logic to get square root of 4 times the square root of 5. But of course, the square root of 4 is what? It's 2. So this becomes 2 root 5. You can just take the square root of the 4 to get the 2. Oh, man, that writing is so good. I hope that's legible enough for you to understand what's happening. So, like, 20 wasn't too bad because you could probably find the 4. And if not, like, you can just use your calculator to work on finding those numbers. But sometimes it's a little bit harder. So what I would suggest is to do a factor tree. I don't know. What's a good example? Ooh, maybe like 140. I think that one's pretty, like, at least for me, like, I'm not thinking of like, oh yeah, of course it's this. So let's do 140. So the square root of 140, we're going to try and break that down into a mixed root. So what I would do is over on the side, maybe do a factor tree for 140. So I'd break that into 2 numbers. So I might do 14 and 10. And then I might do 7 and 2. And this will break down to 5 and 2. Okay. So those are all prime numbers, and that's sort of the end of our journey there. So notice that we have 7, 2, 5, 2. If we put that in order, that's 140 equals 2 times 7, whoops, wrong order. 5 goes before 7, times 5 times 7. So what you can do is look for pairs of numbers, and you might actually come up with more than one pair. So you might need to take out more. But in this case, we have 2 times 2. Right there, that's signaling to us that we have that we can take a perfect square of. So it turns out that that number is what we want to pull out. So that's going to be our number. So we're going to turn this into the square root of the 2 times 2 is definitely going to give us a perfect square, right? So it'll be 4. And then the 5 and the 7, that's 35. So now I can take the square root of the 4 separately from the 35. And that gives me 2 root 35. So there you go. Notice that when we kind of break it into 2 numbers, we square root the one that's the perfect square, and that kind of drops it down to be it looks like a smaller number. But of course, there's no square root anymore, so it's really just the same number. Okay, so entire roots, mixed roots? If this is still not making sense, definitely feel free to send me a question. We'll just finish off with like, how do you go the other way? So sometimes you're given a mixed root and you're supposed to turn it into an entire root. So you just do the reverse. So let's take an example from the book. What's question 5? Question maybe, I guess that's pretty far along. Do we ever do this? Oh, here we go. Question 9 is an example of doing it sort of the other way. So in question 9, all you got to do is do that process in reverse. So for example, 4 square root 3 is a mixed root. What does it look like as an entire root? So we have to turn this into a product of 2 square roots, right? So square root of 3 times the square root of what? So this one here has to be equal to 4. So the square root of what gives you 4 is basically the question. So you could just square 4. You could just do 4 times 4 to give you what you need to do the square root of 16, right? A square root of, I kind of spoiled the answer because I got mixed up there, but yeah, 16 is the answer, right? 4 and the square root of 16 are the same number. So I just convert that, the integer portion of the mixed root into a square root, and then I can multiply those together. So I'm going to get out my handy dandy calculator. 16 times 3 is 48. So that's the square root of 48. So you can just kind of convert those into those, and hopefully it goes well. There's one last topic I wanted to talk about. I don't want to... these guys are moving. I don't know. Not sure how to get beyond them. 1 second. Well... somehow I got beyond it. Okay, so one last topic I wanted to talk about is just multiplying mixed roots. So multiplying mixed roots, if you have something like, say, 4 square root 3 times, 2 square root 3, then all you got to do is just multiply the integer part with the root part. The integers with the integers and the roots with the roots. So you can just reorder this. It's just this multiplication all the way across. So I can make this 4 times 2 times square root 3 times square root 3. So that's going to work out to be 8 square root 9. And if it turns out that this portion you can do something more with, then do it. So square root of 9 is just 3, so this becomes 8 times 3, which is 24. So there's an example of how you can multiply mixed roots together. And sometimes you can actually do a little bit more simplifying. Who knew that this works out to 24, right? You wouldn't just expect that when you're looking at it. But hey, there you go. That's where these questions kind of are a little bit tricky, right? One other example we could do is maybe like 3 root 8 times, we could do 2 root 2. So if I was multiplying these together, again, I can just multiply the plain old number part, so 3 times 2, with the root parts multiplied together. So times square root of 8 times the square root of 2. So just multiply the roots with roots. And I get then the integers, so I get 6 root 16, which is just going to be 6 times 4, which is, again, wow, 24. Is 24 my lucky number? What's going on here? Sometimes it won't simplify all the way down, so you might need to make this like a mixed number. So 16 isn't maybe the best example. I wonder if I could come up with a better example here. I wish I could go to the next page. Sorry. I'll just delete it, maybe. Yeah, I don't know. Maybe I'll come back with another video once I clear all this out and show you maybe a more tricky example with this. But this video has gone pretty long, so I'm going to pause it here. Thanks so much for watching. I hope this is making sense. And take a look at the assignment that's on Teams for you to try this stuff out yourself, okay? Hey, thanks, Matt, then. Bye.